Hello again. We are continuing our discussion of inequalities. We're stepping it up a notch and we're going to talk about multi-step inequalities. So let's get started. They're a lot like multi-step equations. Really the only thing that we need to worry about is when we have multiplication or division by a negative number, we have to change the inequality sign. Other than that, it's exactly the same. So let's start with a few examples. I've got negative 2x plus 1 less than 5. So just like equations, I want to get my x's on one side and my non-x terms on the other side. So that plus 1 has to move. I will add negative 1 to both sides, and this is what it will look like. Negative 2x plus 1 minus 1 is less than 5 minus 1. Well, the plus 1 and minus 1 will cancel out. I'll have negative 2x on the left, and I'll have 5 minus 1 on the right, which is 4. That inequality sign did not change. It's still a less than because I didn't do anything that involves multiplying or dividing by negative numbers. Now I need to divide both sides by negative 2 to get rid of the negative 2 that's right in front of the x. Now I need to worry about things. Okay? If I divide both sides by negative 2, that's when I need to change the inequality sign so that less than will now be a greater than symbol. So I actually divide that, the negative 2's cancel out, and x will be greater than 4 divided by negative 2, which is just negative 2. Okay. Here's another example. 4x minus 3 is greater than or equal to negative 19. I'm going to add 3 to both sides so that on the left-hand side, the plus 3 and the minus 3 will cancel out. And then I've got 4x on the left, and I've got negative 19 plus 3 on the right, which is just negative 16. So no change to the inequality sign yet. I'm going to divide both sides by 4 now to get x by itself. So if I do that, notice that I'm dividing by 4, which is a positive number. So that is not anything I need to worry about. That greater than or equal to sign can stay a greater than or equal to sign. Just because 4 that I'm dividing by, that's not a negative number. Okay, the 4's will still cancel, and I'll get x is greater than or equal to negative 16 over 4, which is negative 4. All right, so now let's do one that has the variable on both sides. Negative 6x plus 3 is greater than or equal to negative 4x minus 11. So I've got x's on both sides, so I just randomly decided to add 4x to both sides to get rid of the x's on the right. So if I do that, I get 4x minus 4x on the right, which is going to cancel. On the left, I've got to simplify that 4x minus 6x. That is negative 2x. The plus 3 stays plus 3, the minus 11 stays minus 11, and more importantly, the inequality sign does not change. Okay, so now it looks like a two-step equation. I need to get rid of that plus 3 on the left, so I will add negative 3 to both sides. If I do that, this is what it looks like, and you see the plus 3 and the minus 3 on the left. That will cancel out. So I've got 2x greater than or equal to negative 11 minus 3. So negative 2x is greater than or equal to negative 14. Okay, so now I just need to get x by itself, so that means I need to divide by negative 2. Okay, negative 2 is a negative number, so when I divide both sides by negative 2, that inequality sign has to change. So greater than or equal to becomes less than or equal to. Okay, and now I simplify both sides. The negative 2's will cancel on the left, leaving me with just x. And on the right, I've got negative 14 divided by negative 2, which is 7. So how do I graph this? I look for 7 on the number line. And since I want to include it, that less than or equal to means I need to include the 7. So I'll put a solid dot on the 7, and the numbers that are less than 7 are on the left of it. So that's how you solve multi-step inequalities. If you have any questions, please let me know, and I will see you tomorrow.